Can you solve this question in less than a minute? If you can't, and you're planning on taking the GMAT, then this video is for you. So what are we going to cover? We're going to cover all the quick tricks for knowing if a number is divisible by something. But we're also going to see the cases where, well, there is no quick trick, right? So for example, dividing by 13, what's a quick way of doing that, right? And that's probably the most important part of the video. So if you're not familiar with divisibility, if you don't know the quick shortcuts, and you don't know how to deal with the odd numbers like 13 or like more complicated ones, then stick around and we'll cover all that. Divisibility essentially means when a number can be divided by another one in a way that there's no leftover or no remainder. So basically it goes exactly into another one. To take a simple example, we can check whether 10 is divisible by 2, and it is, because if you do the math, if you do the long division, you can see that it goes 5 times and you're left with nothing at that point. So in that case, we can say that 10 is divisible by 2. Mathematically, the way we write this is 10 equals something times 2, and that something has to be a round number or an integer. So here, as long as we can write that 10 as 2 times 5, we have that divisibility case. Now, there are other ways of saying that in math, and sometimes the way questions are phrased in the GMAT are a little bit different. So we can write, for example, that 2 is a factor of 10. We can also say that 2 divides 10. We can also say that 10 is a multiple of 2. So all those are ways of saying the same thing in math, and in the exam it tends to jump between one and the other. Let's try another example. So let's say we're trying to check whether 130 is divisible by 13. So what we're doing is we're going to look for a number such that 130 equals that number times 13. And that number has to be a round number, otherwise we're cheating. It turns out that we can write 130 as 13 times 10. And 10 is a round number, so we're good to go. We can say that 130 is divisible by 13. We can say that 13 divides 130. 13 is a factor of 130, or 130 is a multiple of 13. So we can easily check if a number is divisible by 2 just by looking at the last digit and checking if that digit is even. So as a reminder, even digits are 0, 2, 4, 6, and 8. So if we have the number 24, for example, and we want to check if it's divisible by 2, we isolate the last digit, and that's 4. And is that one of the even digits? Yes, it is. So in that case, we can say that 24 is divisible by 2. Let's take another example. 135 or 135. So again, we only look at the last digit. And in this case, it's 5, which is not an even digit. It's an odd digit. And therefore, in this case, we cannot say that the number is divisible by 2. One way of checking whether a number is divisible by 4 is to just look at the last 2 digits and check whether that number is divisible by 4. So, as an example, 1236, we're trying to check whether it's divisible by 4. So we first isolate the last 2 digits and we get 36. And then we check whether 36 is divisible by 4. And we can write 36 as 4 times 9, which means that 36 is divisible by 4, and therefore 1236 is also divisible by 4. The reason why this works is because any number bigger than the last two digits will essentially end in 00, and it will be divisible by 100, and therefore 4 will also go into it. Let's see now how we can check whether a large number is divisible by 8. So here, all we need to do is to check the last three digits of the number. So let's take 12,344. If we want to know if it's divisible by 8, we just need to isolate the last three digits, in this case 344. And if that number is divisible by 8, then the whole number would be divisible by 8. And in this case, 344, we can write it as 8 times 43. So the whole number will be divisible by 8. Now, how do I know that 344 is 8 times 43? Well, here we're using another rule, which I'd encourage you to check out, which is the divisibility split method, which essentially allows us to work out whether any number is divisible by another by splitting it. And in this case, we're splitting 344 as 320 plus 24. 24 is divisible by 8 because it's 8 times 3. And 320 is also going to be divisible by 8 because 8 times 4 is 32, and then if you add a 0 on top of that, it will also be divisible by 8. So here we're adding two numbers up that are divisible by 8, and therefore the whole number, 344, would also be divisible by 8. And it's actually for the same reason that 12,344 will be divisible by 8, because anything but the last three digits essentially ends in 000. So that's divisible by 1,000, and 8 goes into 1,000. So 8 will divide that bigger number as well. How do we check if a number is divisible by 5? Well, this one's quite easy. So we just have to look at the last digit, and if it's a 5 or a 0, then we're good to go. That number is divisible by 5. So here, let's say that we're checking if 125 is divisible by 5. We just look at the last digit. In this case, it's a 5. And therefore, that number will be divisible by 5. Now, keep in mind that there's a similar rule, which is the divisibility by 10, which requires to end in 0. Do not get the two mixed up, because for 5, it can be 0 or 5. For 10, it has to be 0. Let's try another example. 120, is it divisible by 5? Yes, because it ends in 0. We isolate the 0, we check whether it's among 0 or 5, and therefore, in this case, since it's a yes, the whole number will be divisible by 5. The divisibility rule for 10 is the easiest of them all. We just need to check the last digits and see if it's a 0. Let's take an example. 125, is it divisible by 10? We isolate the last digit, and that's 5. And since that's not a 0, it will not be divisible by 10. Let's take another example. 120, in this case it ends in a 0, so it will be divisible by 10. Now, how do I check whether a number is divisible by 3? Well, this one requires to add up all the digits in the number. So let's take 123. If I add up all of the digits, so 1 plus 2 plus 3, that gives us 6. And now we just need to check whether 6 is divisible by 3. And it is, because 6 is 2 times 3. Therefore, the whole number is divisible by 3. However, let's take 1, 2, 4. In that case, if we add up all the digits, we get 1 plus 2 plus 4 equals 7. 7 is not divisible by 3, and therefore the whole number is not going to be divisible by 3. This works on any size of number, so if it's a number that's in the billions or so, same principle, you just have to add up all the digits and see if that number is divisible by 3. What about divisibility by 6? Is there a trick for that? Well, yes and no. There's no trick per se, but the way we typically show a number is divisible by 6 is that we show that it's divisible by 2 and by 3. And then we use the tricks of each of them. So for 2, we need to check that a number is even or not. So the last digit, is it even? And for 3, we add up all the digits and we check whether that is divisible by 3. So let's look at an example, 126. Well, we know it's divisible by 2 because it ends in a 6, and that's even. Is it divisible by 3? Well, we have to add up all the digits, 1 plus 2 plus 6, and that gives us 9. 9 is divisible by 3 because it's 3 times 3. Therefore, the whole number will be divisible by 3. And if it's divisible by 2 and by 3, it's going to be divisible by 6. The trick for divisibility by 9 is quite similar to the one for 3. So again, we have to add the digits up, and in this case, check whether that sum is divisible by 9. So let's take an example, 999. If we add up the 3 digits, so 9 plus 9 plus 9, we get 27. 27, we can write that as 3 times 9. So therefore, the whole number will be divisible by 9. And we can actually check that because 999 is quite easy to see that it's 9 times 111. Now, when we're adding up these digits, so 9 plus 9 plus 9, and we get 27, we can actually do that trick again. So 27, we could just add up the 2 and the 7 to get 9, and 9 is divisible by 9, and therefore the whole number will be divisible by 9. Let's take another example, 123. In this case, 1 plus 2 plus 3 equals 6. That is not divisible by 9. It is divisible by 3, but not by 9. There's a useful property or trick that we can use for divisibility, and that's the following. So when we have two numbers, so in this case 12 and 18, we know that they're both divisible by 6, right? So we can write 12 equals 6 times 2, and we can write 18 as 6 times 3. Well, when we add those two numbers together, so 12 plus 18, that will always be also divisible by 6. And we can check. So 12 plus 18, that's 30. 30, we can also write it as 6 times 5, so it means that it is divisible by 6. Now, this also works for subtraction. So if we do 18 minus 12, we get 6, and that number will be divisible by 6. And of course it is, because it is 6, right? Now, you're probably wondering, why is this useful? I already know, Graham, that 30, for example, is divisible by 6, right? Because I can just write it as 6 times 5, or I know it from my times tables. Well, where this trick comes into play is usually for more complex numbers, right? So let's say that we've got a question where we're talking about divisibility by 17. Right? And we know, for example, that 1,700 is divisible by 17 because it's just 17 times 100. 34 is also divisible by 17 because we can write it as 17 times 2. Well, if I subtract one from the other, so if I do 1,700 minus 34, that number, which is 1,666, is also going to be divisible by 17. And that is not something that's obvious, right? You could check on your calculator, it's equal to 17 times 98. Now, this is something that you're not expected to know in the tests. However, using this method of breaking down into two numbers and subtracting one from the other to show that it is divisible by 17 is something that could be expected of you. Let's talk about divisibility chaining. So what is it? It's the idea that, for example, when we have three different numbers, in this case A, B, and C, and we know that A divides B and that B divides C, then we can chain them together and say that A divides C. And this is actually true for any number of numbers. So to illustrate, we know that 2 divides 6, and we know that 6 divides 18. Right? Remember, if we write 18 as 6 times 3, that means that we can say that 6 divides 18. And so if we have 2 divides 6 and 6 divides 18, then we can chain those together and say that 2 divides 18. And this is true, right? Because we can write 18 as 9 times 2, or another way of showing that 18 is divisible by 2 is just because it's even, right? It finishes with an 8, which is an even digit. Okay. Now notice that it's important that the middle number is the same here when we're chaining, right? So the B in the first sentence is the same B in the second part of the sentence. Now, when do we tend to use this? It tends to be in more complicated examples, and in particular when we don't have full information on some numbers, so when we have unknowns. So as an example, in a question in the test, you could have an x and a y, which you don't know exactly what they are, but you do know that 5 divides x, and you know that x divides y. In that case, you can use this chaining property or trick to say that the first one divides the last one, so that 5 divides y. So the divisibility split method is one of the most important tricks that you can learn in the test, particularly if you're targeting a high score. And what is it? Well, it's essentially the flip side of the addition or subtraction properties that we saw in a separate lesson of divisibility. Now, what does that mean? Well, so when we're trying to show that a number is divisible by another one, but we can't find a simple trick to illustrate that or to demonstrate that. So for example, we're not talking about divisibility by 2, 3, 4, etc., 5, those rules where we have some shortcuts to be able to prove the divisibility. In that case, usually what we want to do is to try and split the number in a way that we can prove that both of the parts are divisible by this divisor, right? So let's talk about this with a example. It'll be easier. So let's say that we're trying to show that 1,326 is divisible by 13? Well, there's no trick for that, right? We don't have a shortcut for showing that a number is divisible by 13. Well, at least not that I know of, and certainly not one you need to know for the exam. But we can split 1326 into 1300 plus 26. 26, we can check quite easily that it's divisible by 13. And 1300, well, it's simply 13 times 100. So that will also be divisible by 13. So we know from the divisibility addition property that when we add those two together, that sum would also be divisible by 13. So in this case, 1326 will be divisible by 13. Now, this also works for subtractions. So, for example, if we did 1300 minus 26, that number, we can also show that it's divisible by 13. This also works for showing that something is not divisible by a number. Right? So let's say the number we have is 1328. We can split it as 1300 plus 28. 1300 is divisible by 13, but 28 is not. And therefore, the numbers, or the sum, will not be divisible by 13. Okay? So here, when you're disproving something, you have to choose a split such that one of them is divisible by 13, or the divider, and the other one is not, right? If you choose two numbers that are not divisible by 13, that does not mean anything, unfortunately. Okay, so now that we've seen all these different tricks and these concepts in divisibility, let's apply them to this example. So if we ask Panda for the solution, and while it's doing that, let me just move my face out of the way a little bit. So we have these 5 different numbers that we're going to test for these different rules. And what we're going to start off with is the rule by 5, right? So why are we starting off with that one? Because it's probably the easiest one to deal with. So remember that for that rule, we need to check the last digit and whether it's a 0 or a 5. If you haven't already looked at that part of the video and you're not sure, I'd encourage you to jump to that video or chapter and cover that. In this case, we're evaluating different options, right? And the only one that does not end in a 0 or a 5 is A, right? Ends in 3. And so that one is not going to be divisible by 5. Okay, so we can cross that one out, and all the others are potentially candidates to being the right answer, so we leave them for now. Okay, after that, we're going to use the divisibility rule for 8. And for that, remember what the rule is. We want to check the last 3 digits and check that those 3 digits together make a number that is divisible by 8. So don't get confused with the other rules where, for example, 4, it's the last 2 digits, right? And for 5, it's the last digit, okay? The first one that we're evaluating is 1800. And as you can see, that is ending in 800, and 800 is just 8 times 100. So we know that that one's going to be divisible by 8. Tick. Okay. For 2340, right, which is the next one on the list, for that one, what we're going to do is, well, we're going to first look at the last 3 digits, because that's the rule, right? But then what we're going to do is we're going to use the split method. Okay. So remember what the split method is. We find a number that's quite close which we know is divisible by, in this case, 8. And then we're going to split the number between that and a remainder. And so in this case, 340, well, we know that it's 320 plus 20. Why are we choosing 320? Because 32 is 8 times 4, right? We know that from our times tables. And therefore 320 would also be divisible by 8. In fact, it's going to be not 8 times 4, but 8 times 40. So in that case, we know that 320 is divisible by 8. We just need to check if the leftover or remainder is divisible by 8. And is 20 divisible by 8? Well, no, it's not, right? Because if we check, 16 is divisible by 8, 24 is divisible by 8, but not 20. And therefore, that one is not going to be divisible by 8, so we can cross it out. Okay, so now let's look at 3,510. Right, again, we just take the last 3 digits because that's the rule of 8. 510, we can then split it between 400, 80, and 30. So notice that here I'm splitting it into 3 numbers, right? And that's also allowed. As long as all of them are divisible by 8, we can then show that the number is divisible by 8. So why are we splitting into these 3? Because, well, 400 is 8 times 50. All right, that's quite an easy one to do. 80 is just 8 times 10. Easy one again. Is 30 divisible by 8? Well, 8 times 2, 16, and 24, 32. No, it's not divisible by 8. And therefore we can cross this one out as well. So at this point, we've eliminated 3,510, 2,340, and 1,173. So we've only got D and E left, and we've checked divisibility by 8 and by 5. Right? So what are we going to do next? Well, 4, actually, we don't have to check that in detail. So there is a rule for dividing by 4, as you probably have seen in the rest of the video. But here, we can use a quicker way of showing that it's divisible by 4. Why? Because we can use the chain rule, right? Which is to say that if A divides B and B divides C, then A divides C, right? So remember the example we use, if 2 divides 6 and 6 divides 18, which both of those are true, then we can show that the first one divides the last one. 2 divides 18. And in this case, well, A is going to be 4, right? And B is going to be 8. Why are we choosing those numbers? Because we've already shown that 8 divides the remaining numbers. And therefore, since 4 divides 8, we actually don't have to check that 4 divides the remaining numbers because we already know it via this divisibility chaining rule. So we can just skip on to the next digits check, which was 9. And so for 9, what's the rule there? Well, again, there's a recap here, or jump to that part of the video if you haven't already seen it. But for 9, we have to sum up all the digits and check if that number is divisible by 9. So for 1,800, that's going to be quite easy because it's 1 plus 8, then just some zeros. That gives us 9. And is 9 divisible by 9? Yes, of course it is. Right? So that one will be divisible by 9. 4,680. 4 plus 6 plus 8 plus 0 is 10 plus 8, 18. 18 is divisible by 9? Yes, it is. It's 9 times 2. So that one would also be divisible by 9. So unfortunately, we can't rule out any further numbers with this check by 9. Okay. Now, bear in mind that if you're actually doing this in the GMAT, you can choose the order of these different checks in a way that's much quicker to rule out as many numbers as possible, as fast as possible. All right. So that's how you do this question in a minute. Okay, and it is perfectly feasible to do it with practice in a minute, I can assure you. Okay, so last but not least, we need to check by 13. And there is no trick for that directly. However, there's this universal split method that works on any number. We just need to know what's the best way to apply it. Right? So for 1,800, and we're trying to see if it's divisible by 13, think, okay, what is a easy number that I can calculate that's not too far off, that I know is going to be divisible by 13? And the simplest one is just 1,300, because that's 13 times 100. Now, 1,800, if I split it, so 1,300 plus 500, then I check if that number is divisible by 13. And I could try it again, right? I could use the split method and this time choose 390 and split it between 390 and 110, 110. Now, why 390? Because I know that 13 times 3 is 39, and then times an extra 0, or 30, would give us 390. So again, I know that 390 is going to be divisible by 13. And then we're left with 110. Is that divisible by 13? Well, it's not, right? Because I know that 130 is divisible by 13. And if 130 is, if I remove 13 from that, I'm going to get 117. So I can rule out that number that way, right? So notice how I'm carefully choosing how to use the split method, and I use it in different steps if needed, but always keeping the math very easy to do. And then the last one is 4,680. Here I split it as 3,900 plus 780. Why do I choose 3,900? Because again, we've got a 39 in there, which is 13 times 3, and then I just have to add some zeros on it. Okay, 780 is 390 times 2, and 390 is, well, 13 times 30. We've already seen that. So this one will be divisible by 13, and it just happens that that 4,680, which was the option D, actually passes all our checks. And that's why that is the answer. So hopefully this was helpful. Obviously this comes with practice, right? It's not just about learning these rules, but it's also being able to apply them very quickly. And so if you go into the GMAT Panda app, you can practice a lot of these rules and add them to review list, and just constantly drill on that particular set of methodologies until you really get them instantly, right? Because in a GMAT question, you need to do it in roughly 2 minutes. And if it takes you 20, 30 seconds to remember each of these rules, you can see that it's not going to be possible to do it in 2 minutes. And the strong testers are going to be able to do this one in a minute with some good practice.